Hello, you absolute legends. This is a supplement to the rate of reaction lab as performed in Chemistry 152. That lab is about determining the order of reactants with respect to the rate law. The order of the reactants refers to these superscripts that are just like exponents. And in chemistry, they give us an idea of how important that reactant is to the rate of the reaction. To be fair, every chemical is important because it is part of the chemical reaction, but some are going to affect the rate differently than others. Consider these two experiments here. This is the molarity of each reactant at the initial, and this is the rate that each reaction took before it went to completion. The initial molarity for the KMnO4 is changing, and the initial molarity here is identical. Yes, when we want to study only one variable, when we want to study things, we only want one variable. This varies, this stays the same. So because this varies or changes, and because this stayed the same, we are going to see how the rate of the reaction, how this KMnO4 affects the rate of the reaction. So solving for X right here. Proportionally, let's compare these two. Proportionally, 0.012 divided by 0.022. This is a proportion of these two experiments. This is also a proportion comparing the rates of these two experiments. Because this are numbers about KMnO4, we're going to find out how important it is to the rate of the reaction. Well, cursory, just looking at it, if we double the concentration, it does not affect the rate. Okay, doesn't sound that important. If we have more of it, doesn't affect the rate. So mathematically, how that looks is these two numbers here divided by each other, kind of a rough round, comes out to about 0.5x. These two numbers here come out to 1. Solving for x. The only way to make this exponent work is if x equals 0. So if x equals 0, no matter what this number is, it will always equal 1, which is what we want it to equal here. So the value for the order of the reactant for potassium permanganate is 0 based on experimental data. What that means is it doesn't matter what this concentration starts with, it's always going to be to the 0 power. It's never going to affect the rate of the reaction. I hope this helps. Thank you.